If you have taken physics, you may have already talked about significant digits, sig digs, or also called significant figures, sig figs. Full disclosure, I call them significant digits and sig figs, so there you have it. Now, if you've taken physics, you've already talked about this a little bit. If you haven't, we're going to go through it. There are going to be a couple of places where I and the physics teacher disagree a little bit. There's some reasons behind it, but it's one of those things where there's not a great answer, and it kind of depends a little bit on a few things. The good news is it's rarely going to matter. It's rarely going to happen that we've got that particular issue. Okay, what are significant digits for those of you who haven't had them? Significant digits come down to the idea that there's two different kinds of numbers in science. I know that numbers are numbers, but no, they're not. Certain numbers are exact values, and if I'm counting things, if I have numbers that are defined, so 1 liter is 1,000 milliliters, those are defined units. Those numbers, they're exact values. The other one is measurements that are not exact values. So they always have uncertainty. And then the amount of uncertainty depends a little bit on what you're using to measure them. So for example, if I have a ruler that looks like this, where the numbers go from 1 to 2 to 3 to 4, well, I could also have a better measuring device where I've got the little minor ticky marks in between. So now whatever I measure, I could measure exactly the same thing, but if I'm using these two different measuring devices on it, I could end up with a better number using the better ruler. And then the other one, I'm going to probably be making bigger guesses. Okay, we need to talk about some terms. There's accuracy, is how close a measured value comes to the true value. Now you might be wondering, how do we know what the true value is if we're measuring it? Well, it comes down to measuring it, trying different devices, getting different people to have it. But once we're dealing with stuff in science, like say for example atomic masses and things like that, the true value, quote unquote, is going to be one that's generally accepted by a lot of people. So theoretical values, we consider those to be true values. Experimental values, we hope they approach true value, but what we'll find is that if you do an experiment a bunch of different times, all your numbers will be a little bit different from each other, and then we tend to take the average of them and say, okay, well, we eventually got there once we did it enough times. The other option is precision, and that is effectively the place value that we can, how close we get to that. And I guess maybe a picture is going to be a little bit better, but as an example, is the temperature 15 or is it 15.3? That would be a matter of precision. Those two numbers are rounded off the same. Not sure which one would be closest to the true value, but one has much more precision to it because the measuring device allowed us to get to that decimal point. Okay, if I take a look at this, first one here, not very accurate, not very precise, all over the place. The second one, there's a lot of precision there. All of the measurements or all of the attempts at the target are hitting exactly close to the same spot, but definitely off of the bullseye. The next one, the third one here, we're getting pretty accurate, right? We're getting around that true value. We're getting around that bullseye, but we're kind of off every single time in terms of what we're trying to beat. And then this last one, now it's much more, it's accurate. It's also much more precise because that cluster of misses is closer to the true value, and looks like a couple of them actually hit the red dot. So that's what we mean by those two different terms, accuracy and precision. Okay, if I were to ask you to take that first measuring device and measure the length of the red bar, you would have to guess at the 2 and a little bit. The 2 is obvious. The little bit, well, how much? It's maybe a little bit less than half, but maybe is it more than a quarter? When I did it, I would have guessed that to be about 2.3 centimeters, but that 0.3 is a guess, and you might have guessed differently. That's kind of what we're talking about. If I used the better measuring device, or at least the more precise measuring device, and then I look at it more carefully, I can actually tell that it's a little bit bigger than 0.3, but not quite 0.4, it's somewhere in between, so I could say it's 2.36. More precise more precision in my measuring device, more precision in my final answer. Neither one of those is the true value because both of them had to be guessed to a certain point. Okay, how do I know how many significant digits? And this is where me and the physics teacher and I have a bit of a disagreement, but we'll talk about that when we get there. Leading zeros, zeros in front of a number, are generally not considered significant. I shouldn't say generally, they are not considered significant. So this number, even though there's a lot of decimal points to it, only has 2 significant digits. Trailing zeros, this is the place where it depends. So in the first one, to me, it depends on the decimal point. So if I have 6,400, I would say that that is 2 significant digits. But there is a way to make it 4 significant digits. In physics, you probably would have called that 4. There would have been an assumption you made about the decimal point, even though you couldn't see it. And I'm okay with that. If the decimal point is obvious, then the trailing zeros do count. So in the case of 10.0, 3 significant digits. Scientific notation depends on the number of digits that are present, so 3 that they're showing, 3 significant digits. The times 10 part does not count as a significant digit. It's actually how you would take care of that discrepancy with me in physics, because you could write a number in scientific notation where unnecessary trailing zeros are removed. Anything that's counted or defined values like the number 4, I count 4 people, those are going to, or 30 people, those are going to be completely exact values. You don't worry about significant digits, which means those numbers do not change what we do for calculations. Okay, because calculations are going to be one of our things. When you add or subtract, it's about the number of decimal points. So the number of significant digits in your answer comes down to the smallest number of decimal points in the thing. So if I, in the question, so if I had this, okay, because when I add numbers, I can actually increase my total number of digits. So now I count the number of decimal points. So I would take that added up answer and I would round it to the correct number of significant digits. I would round it to the correct number of decimal points, basically. When I'm multiplying or dividing, it's the smallest number of significant digits is the one that rules. Again, keeping in mind that exact values don't count. So if I had that question, which you see there, one of my answers, or one of my questions, one of my numbers in the question rather, had 2 significant digits, the other one had 3, so my final answer can only have 2. Okay? It's mostly about practice and mostly about getting used to it, and there will be lots of times where you think, wow, I really lost a lot of numbers there because of my significant digits, and that's okay. Now, having said that, there will be times where my particular focus is going to be on doing the actual math, getting the actual calculations done, and significant digits will be one of those nice luxuries that we hope to get to and hope to really think about and pay attention to, but it will be a nice luxury, and our main objective will be getting some of the other things done. Anyway, we'll talk another time.